In today's tutorial, we're stepping into an exciting Python topic, two-dimensional lists. By now you're well acquainted with Python lists, but did you know that you can nest lists inside lists, creating multi-dimensional data structures? A two-dimensional list, known as a 2D list or a matrix, is simply a list of lists. It's a powerful tool for representing structured data like a table or grid. So here's an example of this. So let's call two-dimensional list, and that'll be equal to a list containing another list that contains 1, 2, and 3, and then we separate this at the end of here and create another one, 4, 5, 6, separate that, 7, 8, 9, and I'm just going to add these spaces here to show you. So this is a simple two-dimensional list, but most of the time you don't write them like this because this is a little bit confusing. But first I'm going to show you it like this, and then I'll show you the way that you're usually going to write two-dimensional lists that makes more sense. And so accessing these elements, like I'll show you in the next section of this tutorial, you're actually going to use two indexing brackets. And so instead of using one like you're used to, you'll use two. And so what these essentially say is, okay, well the first one is the first item. So these are each items in the main list. And so let's say we're going to get this item, we'll do index 1 because it starts at 0. And then this next index is actually referring to the item inside index 1. And so this could be 5, so this would be another 1. And this is, we could also do 2 for 6 to make it different numbers so I could show you. So this is saying, okay, well, we're going to access the first item in the list, and then indexing from this item, we're actually going to index the second index, which is 6. And so this is actually how that works. But there's actually an easier way to write 2D lists. So you might actually use this to represent a table with columns. So instead of doing it like how I just did, actually, let's go and hit enter after every item. And so now, this is actually a grid. Because now it actually makes sense. Because when we are going to index this, we can actually do, okay, row 1, column 2, right? Obviously, we're still indexing, so it starts at 0. So row 0, column 1. And so we could actually treat this as a table with rows and columns. And so that's why most of the time you write two-dimensional lists like this. Of course, that's not evaluated any differently, but it does help you understand two-dimensional lists, because when you write them all out in one line, it can look a little confusing. So like I said, you can access elements in a 2D list by specifying two indices, one for the sublist and one for the element within that sublist. Here's how you'd access the number 5 in our previous 2D list. We would just say, we could just print it, for example, two-dimensional list, 1 and 1. So the first index accesses the second list, and the second index 1 accesses the second element inside that list. Or you could actually just think of it as row 1, column 1. Technically row 2, column 2, because we're indexing. And now when we run this, it says 5. Modifying elements in a 2D list is just as straightforward as modifying elements in a normal list. Just like regular lists, you can change an element by assigning a new value to the corresponding index. So let's replace the number 5 with the number 10. So we could say two-dimensional list 1, 1 is equal to 10. And now when we print our two-dimensional list, we get a new list with 10 in the middle. So when you have a 2D list, you actually don't have to use two indexes. So if you only wanted to access index 1, which is this, you could just change this entire thing. And so if you wanted to do that, you could say 10 if you wanted. So now we would get a list containing a list, then just an integer, and then another list. And that would look like this. That's all it would look like. You can also just do a list. So 10, 11, and 12. And so now when we print matrix, we get 1, 2, 3, 10, 11, 12, 7, 8, 9. Because we just changed the entire first element, which is this. You can apply many of the list methods you've already learned to the sublists in a 2D list. For example, let's append a new row to our matrix. So we can have a new list called new row, and that's equal to 10, 11, and 12. And now we can do two-dimensional list.append new row. And printing two-dimensional list would give us the new list. with actually 4 lists inside of it because we've appended this one. And of course, I'm not going to show you every single list method because we've gone over them before. And they're pretty straightforward. It's just using 2 indices or not if you don't want to. And all of the list methods work on 2-dimensional lists. Treat them just like normal lists, except for the fact that when you want to index a specific number inside another list, it's just another index. You can iterate over a 2D list using nested for loops. The outer loop will iterate over the rows, and the inner loop will iterate over each element in the row. Let's print all the elements of our matrix. So we could say for every row in 2-dimensional list, and then for every row, then we will also say for every element in row, then we will print element, and then end is equal to a space. And so this is actually, I want to show you what this means for a second before we do this, so let me just comment this out. When you do any print statement, hi, for example, and you put another argument in this, because print's just a function, just like any other function we've done. But there's another parameter that we can do, which is end, and set that equal to anything we wanted. When you're using a print statement, you actually have to specify what the argument is. So you're used to doing functions like, you're used to doing them like this, right? Argument 1, 2, and 3. But sometimes you actually have to specify what you're actually deciding, because in Python, the order of arguments doesn't always have to be the same. So if the first one was called argument 1 or arg1, you could actually say arg1 is equal to 2. Now this seems a little confusing, but this is just saying that we wanted to set these arguments, and this will all make sense when we're creating functions. But all I'm saying here is that print has an argument called end, and you have to specify with end is equal to something. And so usually the end of a print statement is a new line, so that's default. But if we wanted, we can set that to a space. And so if we did another print statement, you'll notice that it just says hi, space, hello. These are 2 different print statements. So that's all we're doing. We're making it so that we see all the elements printed all out next to each other. And so that's why we're doing that. And then in the main for loop, we'll just say print. This will just be a new line after each row. So the outer loop goes through each row, and the inner loop goes through each element in the row, which is this variable. And so we can just run this, and we actually get the grid. Because for every row, we actually printed each element with a space. And then once this was done, meaning we got to the bottom of this loop, we print a new line, and then it goes again, and the row has changed, and it does that again. As you can see, 2D lists are a powerful and flexible tool for handling complex data structures in Python. They might seem daunting at first, but with practice, you'll become comfortable with them in no time.